Now that we've talked about the long-term trends of the exchange rates, we can start studying the fluctuations around this long-term trend that our series for exchange rate exhibit. So when we think about this fluctuation around the trend, we're thinking about short-term volatility, which is basically how far away a time series is from its normal growth, if you want. There are several ways of measuring this short-term volatility. One way which we will adopt in this lecture is to first calculate percent changes of the original series for exchange rate, and then to calculate the standard deviation of these percent changes of the exchange rate over the entire time horizon that we are considering. The next slides are going to offer a brief recap on the concept of standard deviation and simply how we calculate it, starting from observations that constitute a time series for an exchange rate. And in slide 11 in particular, I provide you with an example of two time series. Both time series have an average of 0, meaning that the average change for this time series over these 10 periods that we're considering is 0. However, the first series, ER1, exchange rate 1, exhibit a standard deviation of 4.96%. This is a first reminder from your introductory statistics class. The standard deviation of the exchange rate or of any economic variable really is expressed as a percentage. So that's nice because it's easy for us to make comparisons between time series if the standard deviation is expressed as a unitless number, as a percentage exactly. But so we notice that the standard deviation of ER1 is 4.96%. The standard deviation of ER2 is 1.41%. So ER1 is more volatile, or it is exhibiting higher volatility than ER2. In slide 14, I'm showing you a plot of these percent changes of the exchange rate over time, and it's immediately evident that ER1 has a higher volatility than ER2 just by the fact that if we look at the magnitude of the variation of ER1 compared to ER2, we see that this magnitude for ER1 is bigger. We see a lot of plus 5% and minus 5% changes, which over time, in a sense, cancel each other, and that is reflected in the average being 0. However, for ER2, the average is still 0, and the changes over time are also kind of canceling each other if we were to sum them over time. However, as you can see, the range of variation for ER2 is way more limited, and we see a lot of plus 1%, minus 1%, plus 2%, minus 2%. So relatively small variations around the mean, which is 0, or average, that is 0 for ER2, and again for ER1, large variations around this 0 mean or average. So anytime we see a time series that is exhibiting this very large fluctuation around a certain mean, we can immediately conclude just by looking at the time series that this series is going to be exhibiting a larger level of volatility compared to a series like ER2 that has tiny fluctuations around the average.